Okay, so welcome to another exciting edition of Mrs. Thompson's math videos. Okay, so we are actually doing the last section in chapter 4, which means I know that we just had a quiz, but now we're already ready for a test. So that's kind of how that works. A lot of times, one week we have a quiz, the next week we have a test. That happens occasionally. So just be aware of that coming up. This is a fairly short lesson on looking at sequences and functions. So basically looking at patterns in a relationship. So the first question here is a mixed review, kind of going over what we did in 4-6. Find the range of the function when given the domain. Sorry about the typo there. If it helps you, you might want to draw a table of values. We know that the domain is going to represent our x values and the range our y. So I could just kind of list off the numbers they have here. And then we just quickly take each of those numbers, plug it in for x. Remember that this is using function notation, so we're seeing more of that, and plugging them in there and finding our range values. So you could press pause and go ahead and do that. I think we could do it pretty quickly though, because it's just multiplying by -4. I also want to make you aware that we usually put them in order. So when we have those values, we want to make sure they go in order. So I usually go from least to greatest. So I would have my funky little bracket there, and then -40, -4, 0, 4.8, and 12. We don't have to worry about anything repeating. Remember, we don't list the number. If it repeats, we only list the value once, whether it's in the domain or the range. So just kind of reviewing that from the last section. Now, in this section, we're talking about sequences. So an orderly list of numbers is referred to as a sequence. So we have a vocab word here. So I like to highlight those. Each number in a sequence is called a term. So that is also a vocab word. Many sequences do tend to follow a pattern. So to find that pattern, it's kind of like solving a puzzle sometimes. I feel like in this unit, especially in this chapter, we've had to look for different patterns when you're writing a function rule and things like that. So in this example, they want us to describe the pattern of the sequence. So what are the next two terms in the sequence? So it's kind of like, okay, thinking out loud. So I could divide 8 by 2 to get 4. So that might be an option. But if I do 4 divided by 2, that does not give me 0. So I don't think that's the rule. So then you start trying something else. So the pattern can't be divided by 2. So kind of look at it again. Maybe subtracting 4 from each value to get the next number. So if we look here, that's exactly what's happening. So in some cases, it's a little bit of trial and error, thinking, what could this pattern be? Are we adding, subtracting, multiplying, dividing? So in this case, the pattern is subtracting 4 from the previous term. So that means the next two terms are going to be -12 and -16. So just continuing that pattern once we have that figured out. So here's another type of pattern. I'd like you to think about it. So this would be a good time to press pause and see if you can come up with the answer. Now, when I'm looking at the pattern, again, I'm just trying to think, okay, what are they doing to the first number to get the second number, and would that pattern hold up as I continue? So just doing a little bit of trial and error, as I said. So I can see here one way to look at it is they're adding 6. So would that hold up every single time? So would it hold up here? Would it hold up here? And I can see each time they're adding 6. So that has to be my pattern. So I would say that the pattern is they're adding 6 to each previous term, or to each term to get the next one in the pattern. So the next two numbers in the pattern, if we continue that, would be 29 and 35. So just continuing along there. So some of your problems today could be fairly straightforward patterns. Some of them might require you to think a little bit more to see if you can find the rule that works. The next part is we have some vocabulary. I know a lot of times we see this word right here and we think arithmetic, but it's actually pronounced differently. It's arithmetic. So an arithmetic sequence is a sequence in which the difference between consecutive terms is constant, meaning every time between terms it's a constant amount, like the previous example we just did. So this difference is called the common difference, another vocab word. So we can find the nth term. That refers to, we can find any term in the pattern of the arithmetic sequence by using the following formula. So mine didn't print off like super well, but this should be a to the n equals a to the 1. That should be a plus sign. N minus 1 times d. So we're going to talk about what each of those represents in this formula. First of all, a to the n is that function notation, a of n, and it represents the nth term, whatever term you're trying to solve for. A to the first, or a of 1, represents the first term in the pattern. N, of course, represents the number we're trying to find, and D represents the common difference. So if we can find these out, we can use this formula, and it works every time as long as it's an arithmetic sequence, as long as we're just finding the common difference, if that's the pattern. So it's not going to work with all patterns, but it works sometimes. So in this problem, it says write an explicit formula for the arithmetic sequence, and it gives us a pattern. Remember, it has to be a constant difference. So if we look here, the book is showing us they're adding -5 to every term, or you could just say subtracting 5 to every term. So we have our formula here. So we're going to plug in the values that we know. We know the first term in the sequence is 15. So this term right here would replace the a to the 1 in the formula. So that's what they did here. Then we don't know what term we're trying to find yet, but we do know that D is minusing 5 or subtracting 5 each time. So we can plug in minus or -5 for D. So now the next part is, there's our formula. There is our formula for this particular sequence. And now it wants us to use the formula to find the 10th term in the pattern. So that means for n, we're going to plug in 10. So this is what it looks like. So a of 10, that's the term we're trying to find. We're going to plug in 10 for n here as well. And then we're just going to work out the problem using order of operations. So we end up with a of 10 equals -30. Using, again, order of operations. So we did not have to just write out the problem through 10 terms. We can just use the formula. But it only works in these kinds of cases. So don't think you can use this formula on every single pattern you see, because that's not going to work. Okay, so excuse me. In this example, I want you to identify the arithmetic sequence. So actually in all of these, I want you to write the formula, and then I want you to find the 10th term for each one. So I'm going to give you some time to do that. So why don't you guys press pause and go ahead and answer problem 2, and then go ahead and answer 1, 2, 3, and 4 using that new formula. Again, I'll do some with you in a minute as examples, but I really would like you to try first before you see the explanation. So I'm going to stop the video here. I want you to do those, and then you'll have to go to the next video to see the answers, okay? See you in a minute.